Welcome to another episode of the AI Lab Unfiltered podcast. I am Drew Veach from BizStream. I am joined by Mr. Pete Terryn from New Wave.
Good morning.
Very lively. So we got a really good episode today, but we want to start out by saying, obviously, we're not in our normal studio. We're trying something different. It just kind of opens up, removes some of the barriers to get more people coming in remote that are further away. We do want to give a big shout out to Think Tank Thought Leadership. They really do handle a lot of our production, our post-production. They're going to edit a lot of this together at the end. They handle all of our publishing. When you go to Apple, when you go to Spotify, when you go to YouTube, they're the ones that are responsible for putting those out there, making sure all the keywords are correct, making sure all the socials are correct, making sure it looks good, making sure everything is just buttoned up. If you're looking to do a podcast, I cannot stress it enough. Pete and I talk about it all the time. Go to Think Tank Thought Leadership. They really know how to handle it. They really know how to put it together for you.
Yeah, and you're not seeing it today. If you watch previous episodes, you know they have just an awesome studio set up that we've been fortunate enough to be in and be a part of, providing all the lighting and the microphone and the production and switching cameras, and they do all that stuff for you. And as I like to say, if you want to be cool, have a podcast. And if you're going to have a podcast, you might as well do it with Think Tank Thought Leadership, and they're awesome to work with.
Or as I say, if you want to pick up chicks, have a podcast.
Yeah, it's awesome for that too.
Still hasn't worked for us. So we have a great episode today.
Yeah, people tell us that it's good for that.
Yeah, people tell us. We have yet to see it. So I am going to bring in our guests. We have Drew Morgan and Joe Dyer from Disher. Welcome, guys.
Hello. Thanks for having us.
Yeah, thanks for having us.
So I'm glad you guys could make it on here. I know you're familiar with our show, familiar with the AI Lab, the meetup group. Drew, I think you've been part of that since the first day we had it.
Yeah,
we've always seen you around and been in the same circle. So it's nice to have you guys on to kind of talk more about this more in depth, one-on-one with us.
Yeah, it's exciting.
So give us a little bit of background on who you guys are, what you guys do at Disher, what Disher does.
Yeah, I can start. Yeah, Drew, I saw you nod. And so I was like, okay, I think that's my cue. Yeah, Disher, we're in Zeeland, Michigan, and we have 3 brands. It's Disher Engineering, Disher Talent, and then our Lean by Design brand. And we're a professional services firm focused on all things engineering, kind of from product to launch. And then we also help with talent recruitment and leadership development and kind of all things tech, including AI. And so we're always able to work with our customers and work in the industry to uncover new use cases for all types of tech. And so we're excited to be here and talk about it. And I'm able to lead in a lot of those spaces. Drew?
Yeah, Drew Morgan. It's funny to have 2 Drews on here, right? Could be some confusion later. We'll try to play that up as much as we can. I am on our innovation and design team. My background is in mechanical engineering, but I studied robotics in grad school, and so life is funny how you take opportunities as they come and end up in places you never thought you'd be. So. I do not do robotics right now. I work in our kind of front end engineering team. So a lot of people have product ideas, but there's a big fuzzy front end thing of like, well, how do we start? I know there's a solution for cutting metal, right? There's lots of businesses that do this. I know there's solutions for making drawings of parts, like Disher does that too. But when you're trying to answer the question, what product should we make? Like, what does the market want? Where's the fit? How are we going to earn money with it? Like, all those kinds of questions should be answered first before you really start engineering. And so that's what the Innovation and Design Group does that. We do some user research, market research stuff. We do quick prototype testing. I don't know if you've ever heard of fail fast, but I'm always preaching that like find your riskiest assumption, find your find a thing that you think is going to be the hardest and poke that first and just see like, hey, can we prove that this is going to fail? And if you can't prove it's going to fail, well, maybe you should keep going.
Yeah,
So-
Drew and I are very familiar with fail fast.
And
We add often to that too. Yeah. Watch
Yeah.
every episode of the podcast.
So Drew, with your background in robotics, what do you think, like today's age of the AI being embedded and implemented in robotics, what is your take on it?
Well, this is a little bit tricky because when people talk about AI right now, and you all have mentioned this on your podcast before, a lot of times people are meaning a large language model. And I don't think that from what I've seen, and I'm not doing that day to day, right? I'm not trying to apply large language models to robotics.
Sure.
But from what I've seen, and I've read a few papers about it and seen people trying to do that, it doesn't work very well. Because like these are two pretty separate domains. Large language models work with language, and robotics work in a world of like physicality and coordinates. And especially here in West Michigan, manufacturing robotics work in a world of like micron precision, like repeatability and predictability and reproducibility is the whole point of robotics. As we've all talked about and heard about, large language models are famously not deterministic. Like,
Right.
So maybe more promising fields that, and I don't know how far you want me to go with this, but the most promising connection that I've seen between a large language model and any kind of robotics like application has been actually in like kind of home care, assisted robotics. And this is pretty big in Japan because they have a big need for it. They have an aging population, even more so than we do here. Just not enough younger people to take care of the older people. So they're really investing in this kind of robotics, but it's happening here as well. I went to IROS a couple years ago, which is a robotics conference. It's global, but it happened to be in Detroit.
Nice.
So I was able to attend. And one of the pretty interesting things I saw there was it really was more computer vision, but it was on a robot, using a large language model and a image classifier to look at a scene, let's say in a cupboard, and identify cans, cups, beans, whatever is in the cupboard. That's like the image classifier, which is a pretty well-studied problem. And current generation of large language models have become pretty well connected to that. So you can get good results with text to image and image to text. But then from that, extract like, okay, here's beans, and there's cup in front of beans, and I need beans. So like, you tell that essentially that structure of a prompt, it gets fed to a large language model that then talks it out. Like, I need to take down the cup and gently set it on the counter, then grab the beans, then put the cup back in the cabinet.
Yeah.
And then that can be translated into a high-level motion plan for this robot. So there's some amount of like semantic reasoning that can happen in a large language model that's very hard to reproduce in like a traditional scripting kind of way, or a, the way we've always done code as engineers is like, if this, then that, if this, then that. And you have 1,000 if statements. And you're like, oh, wait a minute. 100 times 100 is more than 1,000. So that kind of connection is what the most promising thing I've seen used right now. And there's a lot of really cool research happening there. It also can involve like understanding what I want from a robot, assistive robot. So it would be very difficult in the past to say like, hey, can you get me the can of beans out of the cupboard?
Mm-hmm.
Yeah.
And then have a robot have any way to like approach that problem, regardless of whether it's a humanoid robot or an arm on a car or whatever the format is. So just being able to understand like okay, he wants the beans out of the cupboard, so I need to go to the kitchen first and like look for a cupboard and then open the cupboard, and like all of these steps that a human does automatically. That kind of talking it out can provide that.
Are you and I don't know how familiar you are with this, but one of the ways that I've heard that they're trying to solve the issues that you're talking about is by building world models. So I don't know if you've read or heard Fei Li, like she's one of the godmothers of AI. She started a company, I think the name of it is Marble. And so you can take images and create virtual worlds out of those images. And then what they want to do is put an AI in this virtual environment and have it learn virtually and then be able to translate that to the physical world. I've only just read about it, but you're the expert in the areas. Or where do you see that going? And like, is that something that you think is the end game, is these virtual training worlds for robots?
I'm going to follow that one down a very long road, just right to the end, right off the bat. I have heard that human intelligence, some theory, no, I don't know if you can even test this, is that human intelligence is the maximum amount of intelligence that can exist in a self-sustaining form, because if you get smarter than a person, that world model you're talking about gets so advanced that you will prefer it to the real world and you will die. Basically is the end chain that of like walking down one road of that. So yes, we're trying to do that. We're trying to say like, okay, humans have a simulation of the world going on in our heads all the time. In the near term, it's very high fidelity. I can throw a ball and catch a ball with my eyes shut almost. Well, I'm terrible at that, but someone can. And you've probably heard this, that there's a lag in our vision. So it's like 100 milliseconds lag between what we see, what we're computing, and what we're actually, the light hitting our eyes. So when a baseball player hits a ball, they are moving in such a way as to hit the ball, but the light has only been processed like 100 milliseconds back. So they're swinging, they're controlling their swing when they're physically seeing the ball halfway to them. So like we're so good at simulating the world in the like 1 second time frame. In the 10-second time frame, we're also pretty good, not that good. We can predict that, those two cars are about to crash in 5 seconds. We can predict, if I drop a ball off a building, about when it will hit the ground, like these kinds of things. And then farther term out from that, we can predict what's going to happen tomorrow. Even just, the weather feels cool, I bet it's going to rain, without looking at a forecast, right? Like we have decreasing levels of fidelity the further down into the timeline. And robots don't have any of that built up, really, except for these world models that people are trying to do. I think it's very promising. I think it can work. I'm also not really an expert, as you accused me of being. But, I have seen that. It's very impressive. I haven't seen it used yet, but obviously the training that you're talking about is going to happen behind the scenes, and we're not going to see that until there's some product of it, if the training worked.
Well, my boys do this, Drew. It's called Minecraft. They're
I actually, there's a bunch of YouTube videos where people are building AIs to play Minecraft. And like if in robotics, also check out Disney Research. They have a YouTube channel. Fascinating. Like Disney is legitimately contributing to the field of robotics right now.
Oh yeah, they have been for a lot of years. Yeah,
last week they had a video about training robots to fall intelligently, and they were doing exactly this world model type. Well, it wasn't an image-based neural network world model. It was like a traditional physics-based simulation. But they would have the robot fall in simulation thousands of times into thousands of different poses and then learn a control method to fall gracefully, and then translate that to the real robot and retrain it in the real world to, finish fixing whatever bugs are left over. The delta between theory and reality, right? And then because it's Disney and they actually have an ROI on cuteness, they programmed it to fall into like sassy poses and play it off as though it's still cool. It's a hilarious video.
You know what's interesting about that though, Drew, is like Disney's in the business of world building, so it actually kind of makes sense that they're doing that. It's probably not. It's somewhat of an adjacency to what they're doing every day.
So if you take Drew's talk tracks and put them together, Disney's creating the end of the world as we know it, because they're going to create such a fascinating world that will be so enthralled that we'll all die in there because we'll never want to leave. So thank you, Disney, for ushering in the end of the human race. That's awesome. I didn't know the podcast was going to go there today, but
they're not the only ones who are trying to do it though, right? Like that, the world model that you talked about is actually pretty different approach from that.
I'd love to quick comment on this. Like maybe, my background, I might have mentioned it in the beginning, but my background's a little bit more on the manufacturing shop floor side in terms of technical background. And there's been AI systems for a long time. I mean, I would say there's automation to machine learning to AI. And I know you guys have talked about that.
Sure.
Specifically in this world building model, I mean, there's been digital twins for a long time. I mean, I couldn't give you the complete origin, but a decade there's been digital twin work where you're building up systems, you're building up mechanical, physical systems in kind of a world, and then you're testing especially as it relates to output, throughput, quality, optimization. I mean, these things have existed for a long time. Probably the advances in it and the advances I see coming would be a little bit more around using AI as a tool and as a platform. And again, I'm not just talking large language models, but I'm talking, optimization problems that AI is uniquely situated to really find these optimization solutions to problems that would just take a really long time for humans to solve. We might be able to solve them, but we can get through way more iterations of failure modes and optimization than we ever could just because of the compute power.
Are you talking like you could simulate your shop floor with different layouts and you could run simulations and see what kind of output you would get if you put this machine here? Is that more okay? Are there success stories like that you've seen that people have actually done that, or is that still future looking?
No, I think there's, I couldn't rattle off an article or anything off the top of my head, but I've seen it firsthand where you take a MES system, so basically a data input system for manufacturing output on a shop floor. MES systems are getting more and more advanced, and being able to take all kinds of disparate data from sensors on the shop floor that already exist, and this has been decades in the making, to be able to take that data, input it into a system. Originally, it would be like a dashboard output, but now it's becoming more and more where you can start to visualize those things and visualize exactly what's happening. And that's kind of that digital twinning idea.
Okay.
And so it's been a big push in Germany for a number of years. Where I've seen it work is basically being able to visualize it on a computer screen. You can do it just like, if you remember Roller Coaster Tycoon, you could like speed it up, you could speed it up and say what was happening with all of these inputs.
Yeah.
Think about that like to the nth degree on a manufacturing line to say, if I change this, then what happens? And kind of the next iteration of that is the application of not just machine learning, but artificial intelligence to be able to optimize those problems.
So you can really gamify your floor. That's really cool to think about. Because then you've got this whole generation of gamers that have come up. They'd be perfect people to apply for those kinds of jobs, and because they're already used to living in this digitally created world, right? You just need to teach them, some about business and about manufacturing, and they could take those two things and blend them together. That'd be I have to talk to my son. He plays enough video games. He might be a good applicant for that role.
So I just was at a client this week, and this is the first time I've heard it in this way. They were saying it was a large manufacturer, and they're basically saying that one way in which they're designing their UIs on their shop floor is to do it much more similar to what people are experiencing, especially what kids are growing up with in terms of iPads and apps and the UIs that are pretty intuitive. Where if you've been in manufacturing for a while, you know that there's ERP systems and MRP systems and things that are, kind of green input lines and AutoCAD, you type shortcuts, and that's just not the way that software works nowadays. And so they're actually designing their equipment that they're building. It has a PLC underneath controlling everything, but on the top layer of the user interface, they're doing it a lot more like an iPad or an iPhone or an Android or a Chromebook, because that's what kids are familiar with, and that's what actually will drive them to be able to, they don't need training then. They don't need as much training on how to interact with these things, where 10, 15 years ago, it's even with training, it's difficult to interact with a PLC and an HMI on shop floor.
Yeah, because it's built by engineers who understand what they're building. They don't have the UI in mind as they're building it.
That's why it always comes out the iPhone sexy version.
Yeah,
always comes out where it's just super user friendly.
Yeah, and I think you're going to see more of that. I think that Drew, you kind of had an interesting point there around robotics. Like, I think we're almost talking about two subsets of problems or two subsets of solutions to those problems, where there's one, like you mentioned, grabbing the beans. That's like an open story problem, like an open world problem. And a lot of manufacturing is not that. It's closed and constrained, and it's a closed system. And so there's an in-between with cobots. Maybe we could talk about that. There's a little bit of an in-between there. But I think there's almost two different sets of problems here. The fascinating thing to me about humanoid robots, and you're seeing more and more come out, I think the hype is probably a little overdone, but it'll get there. I think what's fascinating to me about that is you're building an open world, open input robot model that is viewing the world without constraint. In manufacturing, like Drew said, you're on the, you're looking toward the micron level of repeatability nowadays, which is a fascinating problem in and of itself. But you're only able to do that because you're constraining so many other things with a lot of times physical stops, physical waypoints, things like that. And it's not super glamorous, but like it gets the job done, and kind of what makes the world go round in manufacturing. So There's two subsets of problems that are really kind of being co-developed here.
Do you want to go into cobots a little bit? I'm very intrigued by that.
Yeah. I'd love, Drew, with your robot background too, to jump in here. Cobots came out. I mean, I'll give you the really kind of the quick synopsis. Really came on the market like 10, 15 years ago, and it's short for collaborative robotics. And when you think a manufacturing shop floor, the typical thing you think of is like, you remember in Terminator, like at the end when there was that Fanic robot, it was like kind of, he's going through the it must have been in Detroit or something, but it was a really early Fanic robot, like an arm robot. That's what people think about. And when they think of manufacturing robots, is a single arm or sometimes multiple arms doing a job. This is what you see on automotive lines. This is what you see in a lot of manufacturing today. America is actually...
Kind of jump in real quick there?
Please.
You see fences around those robots for a reason.
Yeah. Good point.
Yeah, because when you see them moving, I'll build on that, Drew. When you see them moving and it looks pretty graceful, and a lot of times they're quiet and a lot of times they're super precise, they are wildly dangerous, wildly dangerous. And, like I remember a video when the Nintendo Wii came out. I mean, this is like 20, 25 years ago. There were some controls engineers that took I think it was an ABB robot, took a very large ABB robot that can darn near lift a car. They strapped like a 5-point harness racing seat to it, and then they connected it to the accelerometers in a Wiimote, like a Wii controller, and we're moving it around with somebody sitting in it. And I'm sure you could Google it and find it. That's not how you want to program those robots. They're very dangerous. Drew's right. That's why you have fences around them. But a cobot, and getting to my point, a cobot, again, came out 10, 15 years ago, I would say. I'm sure development on them has been a long time. It's basically building in really precise sensors, especially force limiters, that you could have outside of a fence or outside of guarding. You can have a robot working side by side with a human being. And they're really easy to program. Sometimes they're even like soft to the touch on the outside. And the force limiters make it such that if you hit it, it'll stop doing what it's doing. It has its drawbacks, which we can get into. It has some very significant drawbacks, but it is blurring this line of kind of open world and closed world. Drew, I'm curious, like your background manufacturing cobots, do you ever run into those?
I haven't dealt with them a lot. I have studied a little bit some related problems, and I'll bring up one that's pretty interesting that most of our listeners may have never thought of, which is how good people are at handing objects from one person to another. Like if you ask me to hand you an apple or an egg or a piece of paper, I can do that and you can take it and it will be seamless, even if we're both not paying attention, we're looking the other way. And it's almost kind of mysterious how we know, like, when is the right time for me to let go. And we've all had these moments where that process fails, right? Like you're not looking at all, and then you're like holding it out and somebody else grabs hold of it and you don't let go. And then there's like this weird tug of war moment before, and maybe you both let go at the same time and falls. Like there's weird ways that can go wrong, but humans are very good at that. Robots are not, and they're getting better. People are working on the problem, but there's like some very, very tiny force cues that are happening there. Like I can feel when someone's hand first touches the object I'm holding, and then that's like I'm also simulating their mind in my mind and their future actions in my mind, so that I can know what I would do or what I think they will do as soon as they touch the object, and then I can coordinate my action through that simulation, that world model in my head. And I think we will solve that. It's just going to take a while. And so cobots, getting back to the point again, are, from my experience, the mass market ones that you could just go buy and install and like integrate into your workflow are not really at the cutting edge of that research, right? Research is always years ahead of implementation and the market. So I think that will be coming, and cobots are going to be getting better and better. There's also weird legal and like OSHA problems and like constraints that are a little bit artificial. Like they're there for a good reason, but that all takes even longer to catch up with state-of-the-art technology.
Yeah, like the regulation even around that, which is something pretty simple, is way behind. The safety standards way behind. And I think when you think about AI and then put that layer on top of it, it's moving so fast that it's just, there's going to be a lot of catch up to do. And so that is definitely a risk in that space.
Yeah, I mean, thinking, you guys heard of like these X prizes where they throw a bunch of money as a prize for, achieving something with technology. For me, the X prize for cobots would be like an Olympic level baton handoff in like a mile relay or something like that, or a 400-meter relay, where if you could get a robot that can run and then hand off that baton at an Olympic level, that I think you've got the cobot thing figured out. Maybe that's the Disher X prize.
Honestly, like what Drew said, I think what I love about what you're saying, Drew, is like the power of prediction and the power of the human mind to predict is, when you think about large language models, and then I'll tie it to cobots here. When you think about large language models, again, a subset, a very newsworthy subset at this point, but a really important subset, they're predicting the next character, the next token, the next thing. when you take that into the physical world with a cobot, or we're using cobot, but it could be any robot at this point. Again, I think to some degree right now it's two separate problems. It won't always be two separate problems. When you think about that, the power of prediction, that's what's going to drive the value add, is how good can you accurately predict what's happening next, and can you do it faster than 100 milliseconds, like what Drew said? Because our world is based on, then kind of a consequence of what you're saying, Drew, is that our world is designed for, especially the world that we created, a humanoid form that can predict things in 100 millisecond time frame. So if you can create robots that can do that, well, of course, the processing power, they can absolutely predict faster than that. We're slow by that stage, but can you do it accurately in an open world
And
without constraints?
and can you do it with 100 watts?
In 100, the human brain.
Because the humans are like orders of magnitude more efficient processing, like just power wise, than the current state of the art.
And people aren't really talking about that. And that's like
that's a good point. That's a really good point. Is that just the processing power differential, if you will? I don't know how that would be overcome, though, of how you'd even match it closer.
So this brings up another interesting thought that is lingering in my head for years. Robotics, AI, the things we've been talking about, and it's specifically what Joe just said of like, can we build a robot that operates in a human world made for humans, like our self-made world? What we're trying to do across the board, if you zoom out, is to create an artificial person in bits and pieces, and we all imagine that someday that will all be unified into one cyborg that is a person, basically, but we can tune and change it and let it be whatever we want it to be, right? We can't really change our own selves that much yet. And people talk about the marriage of those two worlds. But I think maybe one of the most important outcomes of all of this research is that we understand how we work better. Like, even if large language models are a bubble and in 5 years we think about it totally differently, there's some limit to the infinite curve upwards. Well, who knows what's going to happen? Maybe the singularity happens. If that happens, then whatever. But assuming it doesn't happen, there's nothing else interesting to say about it if there's a singularity next year or 2 years. But if 5 years from now, we're going to know a lot more about how we work because of AI research and because of AI research. And I think that, maybe that helps us build artificial people, but I kind of see this as that all of the research we're doing is going to serve as a test bed for understanding ourselves and making ourselves who we want to be. I don't want to get too transhumanist on us here, but I think there probably is a possible future in which there's cyborgs and androids and all of those kinds of science fiction things. And I don't know if you've seen Ghost in the Shell, but the lines are really blurry in that imagined future where what is a robot and what is a person? That's kind of the point of the show. But
you'll hear Elon Musk say that we're kind of already there with our phones. Like, they're not physically plugged into us, but we are kind of cyborgs right now. We have this, especially now with AI, in an accompaniment of a smart assistant that we're carrying around with us, and it's not that long before it's even more integrated into who we are. But to take what you're saying about robots and modeling it after people, and we learn more about people because we're trying to make robots more like people. You see the same thing with business too. If you want AI to be implemented into your business, you have to teach it about your business. So if you're not good at training new employees, they're not going to know how to work well within your organization. So you have to, in order to get AI, you need to be very explicit with those directions, which means you have to go back and start to outline all your processes and SOPs for everything, because AI can't understand it. Just, you can't, like a human, just say, we'll figure it out, because the AI is not going to be very good at that. But if you can dictate specifically how that process works, then AI can be a lot better at helping execute that and offload some of that work for you. So it's the same principle applies to both the physical world and to your business as well.
And I'm just sort of thinking out along those lines, like I think there's a really good parallel here to the previous conversation of kind of open world robotic problems and closed world robotic problems with AI tools. Because if you have an AI tool that's built upon a certain engine, and then it's grounded to your documents and data, that's kind of a closed world problem. And when you are using ChatGPT or Anthropic or Claude or whatever, that's an open world problem. And I think there's actually some pretty good parallels between a closed world problem can oftentimes get you really precise, and it could get you, here's the document that you need. And there's definitely a use case and a solution set there. And there's also one that's open world. And so even as you say that, it's like categorizing that in that way is probably a healthy way right now to think of it, even
Yeah.
if it's going to be more ubiquitous in the future, and those lines are going to get blurry.
It you got me thinking about something that I wanted to bring up with you guys here today. So you had invited me to come sit in on an internal session with a team, an AI team that you had created within Disher, which was a ton of fun to sit in on, and just to kind of see how you guys work was really cool. I always like not being the smartest person in the room, and I was by far the dumbest person in the room for this session. But could you talk about that a little bit more? Because that's something that when I'm talking with business owners about AI, it's one of the things that I'm trying to encourage them to do is to, find some people that are drawn to AI, that want to be a part of building something within the organization. And you guys it's been a while since we've done that. So I'm curious to see, like, where has that gone? What have you seen come from that? Like, could you just expand on that a little bit for the listeners?
Drew, I'd love if you share the process and just kind of what we did that day.
Yeah. We had an internal team, kind of I wouldn't say it's an AI task. It was called an AI task force. It's more of like an AI research and monitoring team, like scope out what we can see about the tools that are out there, applications that are out there, and try to pattern match to anything that could be done within Disher. And what I started to notice is that there's a lot of really cool tools out there that don't apply to Disher specifically. Just our business model is a little bit like odd, maybe, or edge case. We're a contract services company, right? So all of our data is really not our data. It's your data and your data and your data, because I'm working for you at this time, and a few months later I'm working for you. So like a lot of that doesn't translate yet to our internal processes, but I started to see like, hey, we're all very creative, and I think our motto or our mission statement is to make a positive difference. And I started to think like, well, there's a bunch of dots that are not connected here that nobody has time to connect. And so I wanted to carve out like an hour of time to try to connect some dots just for the world, to throw out there, to say like, I don't think Disher is going to apply any of these solutions to any of these problems, but we see them. We see a lot of solutions and a lot of problems because of the doing, working for so many different clients. And so we had a brainstorming session, and the prompt was something like, how might we use AI to enable a brand new type of business model that doesn't work with traditional non-AI tools? And we had a lot of really cool ideas. So that was the process. I don't know that we acted on it.
Yeah, I can comment on that.
A couple of reasons, but go ahead.
Yeah, I mean, like Drew said, we're monitoring, we're watching, we're trying to understand and stay ahead of it for our customer base too, and to say like, what do our customers really need, and what are we working on to be able to understand, help apply, and be kind of that trusted advisor for our customers to come alongside come alongside them. And we pride ourselves on thinking on behalf of our customers. And that means that being up to date on the latest tools and trends and techniques and benchmarking different things. And I know you guys are in, similar lines of work in that sense. And after we got through that, it was almost like we took a step back and said, hey, there's probably more here. And we're in a strategic planning mode right now, which is good. And saying like Drew mentioned, we actually don't want to own your data. That's like part of our value prop is we want to work alongside our customers and help them be the best versions of themselves with their products and their markets and things like that. And we're looking around that room, like you said, Pete, like, yes, really smart people who have a lot of really great ideas. So let's take a step back and really understand, like, where's our value add in terms of IP, in terms of what we can come up with to be able to offer the market something useful and gainful. And so we're sort of in the time of thinking about that and what does that mean for us and our place in the marketplace. And so there's some strategic things that we're thinking about, but it's still marinating at this point. Let's put it that way.
And I think it's less important, like, to say that something was applied coming out of it than it is to say that you guys open the aperture of just how to think about things, because the application will come. But if you stayed this small in your thinking and an opportunity came, it could pass you by because you didn't think large enough. If you start thinking larger and larger, those opportunities will hit, within that larger path.
Totally.
And I think that's way more valuable. And I was inspiring for me to even be able to listen in on what you guys are doing. It was a hell of a lot of fun too, because just to see those brains cranking away on what you guys are talking about was really cool.
I'll add one other thing too, just real quick. Something that I've thought about since then that really was happening then is the difference between known unknowns and unknown unknowns. Mm-hmm. What we did in that event, and this is how humans explore the world and knowledge. We took a bunch of known unknowns and we unpacked them and made them a little bit more into knowns. And as soon as you do that, you find all of the unknown unknowns that they were connected to.
Yep.
Yeah.
And that you're opening up a bunch of doors to look into a bunch of new rooms when you do that kind of activity.
Totally.
That's what I was going to say. It just broadens that, like Pete was saying, it just kind of opens up that aperture of what is out there. And I think it's incredibly beneficial for a lot of companies they should be doing that. Just sitting down and saying, let me explore just what tool sets are out there. They might apply to me, they might not, but at least I know what's out there. So when something does come up, you can go, oh yeah, I actually just saw something online that it was a tool that can do this for us. Or we can add that to a make or an N8N workflow now. Mm-hmm. I think it'd be incredibly beneficial.
Well, there's something about the idea of constraints when you're innovating, and constraints are not a negative. Constraints are a massive positive because it's you're guiding yourself into what do we have to work with in terms of time. What do we have to work with in terms of influence and resources and materials and all of that sort of thing? And you're going to innovate in those constraints. If you forget or ignore them, I think that there's a time and a place for like this wildly open world idea, but constraints are going to push you toward what are we capable of? What's the next step? What's the next step of innovation? And you can really create some amazing things. And I think sometimes companies will, there's a lot of like, yeah, we've tried that. We can't do that because of X, Y, or Z. And I think the power lies in the work that Drew and team do of saying, well, just set that all aside for a second. And let's really have some conversations and have some brainstorming to think outside of that. And even if there are constraints in it, fine. But let's think outside of we can't do that because of X, Y, Z, because the tools are rapidly changing. And so you might think that, but 6 months ago you couldn't, and now you can,
Yep.
I could tie that into another thought real quick that I had just a couple of days ago. I was watching a YouTube video from a guy called Pezza's Work, P-E-Z-Z-A. He does simulations and puts them on YouTube as a Patreon. He has an ant simulator, and he was trying to get it to work better. Like, he has all these little virtual ants. They go collect food and bring it back to their base, and he's using this as a way to explore kind of emergent behavior and emergent intelligence. He was trying to change the way the simulation works to work better with a changing environment. So he had it working pretty well with a static environment, but then he wanted to like move walls and have them solve mazes that were constantly shifting, and they couldn't do it. They would find a trail and stay on that trail, and he'd open up a new path that's shorter, and they didn't care. And to fix the problem, he made 10% of the ants occasionally go off the trail. That was it, and that solved the whole thing. And it took them from static world to changing world. 10% of the workers, like a little bit of the time, went off the trail.
Love it.
That made all the difference. And you can go watch the video and see how that panned out. But I think there's a great application to just regular life, that if you're in a static world, you can optimize to the nth degree and then never look out of those walls. But we don't live in that. We live in a changing world, and you have to constantly check whether X and Y and Z are still true. And you don't have to spend your whole time doing it. Just once in a while, forever.
Right.
You have to check your assumptions. You have to check your constraints.
Well, we got to wrap this up. Appreciate you guys being on here. It's been fun talking about the cobots and different robotics. I didn't even know where we were going to go with this conversation, but I knew you guys had a lot to bring to the table, so it's kind of fun to understand that. Tell us where we can find you and where we can find Disher.
Yeah. So Joe Dyer at Disher, you can find me on LinkedIn, and then Disher.com. And there's also DisherTalent.com and LeanByDesign.com. So you can go check out all the cool things that we're doing at all those places.
Awesome. Appreciate you guys being on again, and we look forward to seeing what you guys are building in the future. I mean, we'll definitely have you on again, and we'll talk more.
Thanks. Really
Thanks.
appreciate it.
The invite.
Like and subscribe, everybody, and leave a comment and tell us about what you're doing with robotics. We'd love to hear about it. See you, everybody.
Bye.
See you guys.